Welcome to the beginner video series for the GRE. In this video, we are covering the chapter geometry, and in that we are specifically discussing about quadrilaterals. Now before discussing about quadrilaterals, let's take note of parallel lines. Let's say these are two parallel lines. Here this angle will be equal to this angle. These are called opposite angles. Similarly, these two are also equal opposite angles, or you can also say vertically opposite angles. Terminology is not important, but the concept is important. Also, these two angles are equal. They are called corresponding angles. Similarly, these two angles are also equal. They are called corresponding angles. One more thing. This angle is equal to this angle. They are called alternate interior angles. This angle is equal to this angle. Again, alternate interior angles. One last thing. Sum of these two angles is 180 degrees, and also sum of these two angles is 180 degrees. So we have discussed about vertically opposite angles, corresponding angles, alternate interior angles, and that the sum of these two is equal to 180 degrees. Now let's move ahead to quadrilaterals. The first quadrilateral that we are discussing is parallelogram. Now parallelogram is a quadrilateral in which opposite sides are equal and parallel. That means these two are equal and parallel. These two are equal and parallel. The second property is diagonals bisect each other. So this is equal to this and this is equal to this. Diagonals bisect each other in a parallelogram. Third is opposite angles are equal. This angle is equal to this angle. Similarly, this angle is equal to this angle. Fourth, sum of adjacent angles is equal to 180. So these two have the sum as 180 degrees. We've already discussed in parallel lines, if these are two parallel lines, then sum of these two is 180. It is the same concept here. The last point is that area is base times height. If this is the base of the parallelogram and this is the height. Now what is height? Height is the perpendicular distance between the two parallel sides, between the base and the opposite side. Area is b times h. Area of a parallelogram is base into height. Now talking about rectangle. Rectangle is also a parallelogram. Why? Because you have to take note of the definition of a parallelogram. Parallelogram is a quadrilateral. Rectangle is a quadrilateral. Parallelogram is a quadrilateral in which opposite sides are equal and parallel. In rectangle, opposite sides are equal and parallel. So rectangle is also a parallelogram. But it is a special type of a parallelogram. Here all angles are equal to 90 degrees. Rectangle is a parallelogram in which all angles are 90 degrees. The next quadrilateral is rhombus. Rhombus is also a parallelogram because it's a quadrilateral in which opposite sides are equal and opposite sides are also parallel. Rhombus is a special type of parallelogram. Here all sides are equal. Not only opposite sides, in fact all the sides are equal. There is another important property of rhombus that you should know. That is, the diagonals are perpendicular bisectors. Now we know that in any parallelogram diagonals bisect each other, but in rhombus they bisect each other perpendicularly. Diagonals are perpendicular to each other. The next quadrilateral is a square. Square is a parallelogram because in a square all sides are equal, but in a square opposite sides are equal and parallel. That is what makes it a parallelogram. In a parallelogram opposite sides are equal and parallel. In square also all the sides are equal, but more importantly, opposite sides are equal and parallel. Square is also a rectangle. What's a rectangle? Rectangle is a parallelogram in which all angles are 90. Square is a parallelogram in which all angles are 90. So square is a rectangle. Square is also a rhombus. What's a rhombus? Rhombus is a parallelogram in which all sides are equal. Square is a parallelogram in which all sides are equal. So square is also a rhombus. Square is a parallelogram, it is a rectangle, it's also a rhombus. All the three things. It's 3 in 1. Now I want you to try this question. I hope you have done so. Now let's discuss this together. If two sides of a parallelogram are 6 and 8, what is the maximum possible area of the parallelogram? Let's take the base as 8 and 6 is attached at this vertex. This is how the parallelogram looks like. Now, area of a parallelogram is base times height. We have already fixed the base as 8. Now height is flexible. Area would be maximum when height is maximum. This is the height. If we take 6 away from the base, the height increases. If we take 6 away from the base, the height increases. Now there would come a point where 6 and 8 are perpendicular. In this case, 6 is the height itself. As you further incline this, the height again starts to decrease. So the height is maximum when 6 is perpendicular to 8 and the height is 6 itself. In that case, area is 48. So the answer is 48. Height is maximum, and in that case area is maximum. Height is maximum when height is 6, so the area is 48. Or you can simply learn this concept that if two sides are given to you, area of the parallelogram is maximum when that particular parallelogram is a rectangle. This is a rectangle. If two sides are given to you, area is maximum when that particular parallelogram is a rectangle. Now this was about the maximum area. What will be the minimum area of a parallelogram whose sides are 6 and 8? Now again, area is base times height. Base is 8. When the height is minimum, area is minimum. When you bring this 6 closer to 8, the height will decrease. Okay. When you bring it further closer, the height further decreases. There would come a point when 6 and 8 are almost on top of each other. In that case, height is negligible. Height is negligible. The parallelogram looks something like this. Okay. The height is very little. When height is very close to 0, area is also very close to 0. So for this particular parallelogram, area can be anything greater than 0 and it can be anything less than equal to 48. Area cannot be 0 because parallelogram cannot have 0 area, but area can be equal to 48 when that particular parallelogram is a rectangle. Let's move ahead. Now comes the concept of trapezoid. Now trapezoid is same as trapezium. In UK they call it trapezium, in US they call it trapezoid. Since ETS is a American institution, you will get the word trapezoid in your exam. Now trapezoid is a quadrilateral in which at least two sides are parallel. Take note, at least two sides are parallel. The other two sides may or may not be parallel. So all your parallelograms are also trapezoids. Okay. Trapezoid is a quadrilateral in which at least two sides are parallel. You have to know how to find the area of a trapezoid. Let's try and derive it. Though it's not important to know the derivation, you have to know the formula. But still, let's try and derive the area of a trapezoid. Let's take this length as A and this length as B, and the distance between the parallel sides or the height as h. Now let me draw this diagonal. We get two triangles here. This is one triangle, this is another triangle. Okay, let's call it triangle 1 and triangle 2. Area of the trapezium will be equal to area of triangle 1 plus area of triangle 2. What is the area of triangle 1? We can take base as B, so half times base. What is the height? Height is the perpendicular distance from this vertex to this base, which is also h. Now for triangle 2, area is again half times base times height. Base here is A and height is again h. Height is h. We can take half and h as common. We are left with A plus B. So area of a parallelogram becomes half times sum of parallel sides, which is sum of A and B, times the distance between the parallel sides or height. This is the formula that you have to remember. This was the last concept. Thank you for watching this video. I'll see you in the next one.